not always sure how I'm going to teach this class, so it just kind of unfolds, you know, in a discussion. So it's, you know, so vibration of, let's say, a unit of 1, vibration of 2. Okay? This is the first subdivision, half vibrates twice as fast. So the strongest note within any vibration that's the closest to it is a vibration that's twice as fast. And in Western music, we call that an octave. Okay? An octave. And octave means 8, and I'll explain why we have 8 notes very shortly, but it's called an octave. The same, also, if I hit this note here, and then I hit the fundamental, and it's an octave lower. It's half the vibration of this vibration. Yeah, 12th fret on the guitar. And it'd be the same on a piano keyboard. If you're 12 notes away from the original note you started on, that's also called an octave. Okay? So, I got everybody with me so far? Yeah. So, we're just going to keep building on this for a couple of days. And like I said, the math isn't that important, but I just want you to know where we are in this discussion so you have some understanding of it. So if I tell you that an octave is like a half or twice as fast as the original vibration, that is the closest note inside of a note. They're almost identical. They're just vibrating. One's either vibrating twice as fast or half as fast. Right? It could be vibrating 4 times as fast. Instead of that, 4 times as fast would be 2 octaves away. Okay? Right? Or 4 times slower, it would be 2 octaves slower. So it's a, you know, multiple of 2. Okay.
Naively, this music was set up without the math. They came to it.
You hear it, and I'll
this came by hearing.
Yeah, it does come. It comes from empirical science. People sitting there and going, "What the heck is this?" You know, I mean, it's really just like that. You know, and an example of it is, I'll tell you exactly how you can hear. We take our vowel system. I'm just going to put it backwards. A, E, I, O, U. Okay, I just wrote it in backwards. Well, I don't know what to do with my capo. Here it is. I'm going to find a nice note that we can all sing together. So. That sound is the closest sound to the fundamental. Now, as we sing this, I'll just kind of point to the next vowel, so just change the shape of your mouth. So take a nice deep breath. That's overtones. And that's what we hear in every single note. So, you know, we're speaking to each other. You know, the difference between your voice and my voice, even though we're singing the same note, is that, you know, our cavities are set up a certain way, our musical instruments have certain qualities to them. The relationship between the strength of the different overtones is what gives you the character of the sound of your voice or your instrument. Does that make sense? And all that is just you hear the overtones opening and closing, and that's really the core of music. So that's how you know, those guys sitting in the caves figured out that that's how our language is. All you got to do is put a consonant in front of that, H-U, whoo, you know. So you have an attack quality to to the particular overtone inside of one vibration. So, okay? So on page,
So,
yeah,
if, for example, the U resonates like at 100, the O gonna be at
same.
same. Okay.
Same, except that the overtones, which are ringing at higher levels, become more prominent. Just like I showed you when I showed you the little tambura, and you move the string, you're changing the node point, so you're kind of balancing things more towards making the overtones a little stronger. So our mouth cavity in the A sound is wide open, and all the overtones are ringing much stronger. Even though your basic pitch is still the same, the overtones are easier for you to
So
hear.
we're gonna hear more of the partials.
Yeah, hear more.
Better.
Well, yeah, the partials are there. It's a physical law. They're always there. But you shape your cavity of your mouth, for example, to make those louder or softer. You know?
But in the sine wave, there's no partial.
Well, no, everything. Okay, yeah. Essentially a sine wave, which is an electronic signal, is the purest vibration. It would be the purest version of who. Okay, except that nothing is not related to anything else. La ilaha illallah. I mean, this is really the core teaching that everything is totally connected, and so even a sine wave bounces off a wall. It has to come out of a speaker of an amplifier of some kind. It's really hard to get a pure tone because immediately there's this formation of overtones. But it's kind of like you have like on a stereo system, you have your knobs. You have the treble knob and the bass knob. You can boost. That's what you're doing. You're boosting the overtone. So let's say you crank the treble up. You're getting closer to the ah sound with your mouth wide open, and you're hearing all the higher parts of every note that's vibrating coming through the stereo speakers. You crank down, you turn down the treble, and you turn up the bass, and you're going to hear more of the lower quality, the more the fundamental, and then the vibrations of that also kind of generate a vibration in the air half as fast, even though the instrument itself isn't creating it. In the environment, there's like a subtone that you'll hear. So, does that make sense?
And it doesn't matter the language. I mean, for me, like if I read it in French, it sounds really different.
No, vowels are vowels. The vowels are basically. I mean, I think French. You have more vowels
Because
in French,
for me,
right?
it's U, O, I, E, A.
Yeah.
But
Well, but I mean, it's
it's gonna create over.
yeah, there's more vowels in French, isn't there?
Huh?
Are there a couple more vowels in French? Or?
No, it's the same.
Same vowels?
alphabet, but
Okay.
yeah.
I grew up speaking Ukrainian, so that we have a couple more. So, I'm not trying to be too specific. I'm just giving you an example of how our language is formed by the creation of vowels. And every language has their own particular approach to, how they're going to throw the consonant in front of the vowel, and how they're going to shape their mouth when the sound comes out. But the principle behind it is a physical principle. It's the one vibration, and then the overtones that get generated along with the one vibration. Okay? So if we got this far, I'm grateful. So what I kind of want to just kind of go out now and start discussing how people, once they've figured this little system out, how you use it to make music, because So what happens is, let's see, on page 3, I kind of just took the vibration of 100, and I showed you how all the different partials kind of go out from a vibration of 100. We could start at any vibrational cycles per second. The same mathematical formula will be true. There'll be a vibration twice as fast, 3 times as fast, 4 times as fast, 5 times as fast. Each time that sound is particularly quieter.